Seen already, the basic components of an electric drives are a power source, motor, power processing unit, which is generally a power electronic systems or power modulators, the control unit, and the mechanical load. So let us have in detail discussion about all these subcomponents of an electrical drive system in detail. Let us have a detailed discussion about the electrical motors, which is a part of an electrical drive system. We all know that electrical motor is going to convert electrical energy into a mechanical energy. These electric motors obtain the power from the electrical sources. We have varieties of electric motors. Say for example, electric motors are generally classified into two types of DC motors and AC motors. DC motors it is again classified into permanent magnet DC motors and wound field DC motors, which may be again a shunt, separately excited, compound or series motors. AC motors again induction motor and synchronous motor. Induction motor again slip ring induction motor and squirrel cage induction motor. Synchronous motor again it may be a wound rotor synchronous motor, interior permanent magnet synchronous motor or surface permanent magnet synchronous motor, and a brushless DC motor, which is also a part of an AC motor. The selection of a machine on a particular depends on many factors. For example, it depends on the application we use, how much cost we put in that particular application, what is that efficiency, where is that we are going to use, environment, type of source available in that particular place. So the basic criterion in selecting an electric motor for a given drive application is that it meet the power level and performance requirement by the load during steady state and dynamic operations. Certain characteristics of the mechanical loads may require a special type of motor. For example, in the application for which a high starting torque is needed, a DC series motor may be a better choice than an induction motor. In constant speed applications, synchronous motors may be more suitable than an induction or a DC motors. Environmental factors also affect the motor type. For example, in environments like petrol bunks, where environment must be very free and clean from arcs, DC motors cannot be used unless they are encapsulated. This is because of the electric discharge that is generated between the motors and brushes, brushes and its commutator segments. In those cases, a squirrel cage induction motor or other brushless machines are probably the better options. The cost of electric motor is another important factor. In general, DC motors and newer type of brushless motors are the most expensive machines, whereas squirrel cage induction motors are among this or very cheaper. So thus, based on all these factors, only we can decide whether which particular motor and has to suit the environment very perfectly. Now we'll see about the power source, which is the input to the entire drive system. This is the major source which provides energy to the electric motors. The output of the power source may be a regulated, example it may be an utility, or it may be an unregulated supply, generally from the renewable energy sources. Unregulated power sources must be regulated for higher efficiency before it is fed into the motor. Generally, converting an unregulated power source into a form of a regulated one use a power electronic converters. Sources in general can be classified into two types, AC source and a DC source. The DC source, the main sources of DC are batteries, fuel cells and photovoltaic cells. AC source may be derived from a single phase or a three phase utility or from a wind generator. Now let us see in detailed discussion about the power processing unit, which is sometimes also called as a power modulator. What is this power processing unit or a power modulator do in general? It provides a regulated power supply to the motor. It also modulates flow of power from source to the motor in such a manner that motor is imparted speed torque characteristics required by the load. during transient operations such as starting, braking and speed reversal, it restricts source and motor currents within permissible values. Excessive current drawn from the source may overload it or cause a voltage dip. Converts electrical energy of the source in a form suitable to the motor. It is a combination of power electronic converters. It may be a control rectifiers or inverters, or it can be treated as a black boxes with certain transfer functions. It should be more efficient. Ideally, no losses should be occurred in the power electronic converters. It should be very flexible. Voltage and current easily shapes through proper switching control. It is very compact and several conversions are possible with the power electronic converters such as AC to DC, DC to DC, DC to AC and AC to AC. So say for example, if the source is a DC and an induction motor is employed, then the power modulator is required is to convert DC into variable AC. So any such combinations of AC to DC or DC to DC or DC to AC or AC to AC is possible based on the requirement. So the power processing unit is the main heart of the